Je comprends pas. Ça...
C'est là qu'on le jouait, c'est tout fait.
Merci. Merci. Ah ouais, merci. Yeah, please. All right.
Hello.
So I'm having issues here because this is supposed
1, 2, 3.
but it's not. And I cannot use this connector to display. I don't have that. It's
Okay, well, I might have an adapter.
I'll let you figure it out. Sorry, what's that?
I might have an adapter.
Oh, okay.
Let me look.
That might help. Yeah.
Oops, I think I left that adapter in my hotel.
Oh, shoot. So then I'm not sure. It's all I have.
Suboptimal.
All I have is HDMI.
Oh, wow. I definitely don't have that because I realized it's working with 3 of this.
And well, I don't have the slides. I mean, I can see my slides, but that's about it. Okay. 2 slides.
Not a USB drive.
Folks, we're having a little technical difficulties displaying the slides. We don't have a connector that we can actually use from a laptop. So we're asked for help from Mitico. In the meantime, we can go ahead and start. All the slides are up on the site. Oh,
We need an HDMI to DB, what, 15?
Not HDMI, but I have DisplayPort.
DisplayPort? You got a DisplayPort?
I have HDMI. Maybe. Yeah. Yeah, I think so. I've actually never used it.
Let's try it.
Is the same?
Yeah, it's the same.
Okay. So try that one.
Okay. Yeah. It's doing something. So it's
Congratulations. Well, okay.
Yeah, I'm extending, so hopefully. Oh, okay, now we're in business.
All
I
right.
won't be able to see it here. Okay, yeah,
All right.
I think we're in business. Blue sheets, I think Pascal distributed already, so they're circulating there. Excellent. And I don't see the slides. Shit. So welcome to 6th Flow Working Group meeting. One point of business before we start is we don't have a minute taker, jabber scribe. Can anybody volunteer? And again, the minutes is, yeah. I'm sorry, could you say that again? Okay, we have Etherpad, excellent. Okay, so we have minutes. Anybody looking for jabber? Just keeping an eye out for jabber folks. Thanks, Michael. Okay.
Awesome.
We're in business. Note well, I'm not going to read all this. Hopefully you've read it and understand it. And if you don't, this is important stuff. Please make sure you do. Otherwise, you shouldn't remain in the room. Here's the agenda we have. It's, by the way, all this is uploaded on the agenda website. So all the slides are available already. Some of them in both PDF and PowerPoint. More of the agenda. I will note that hopefully we'll get a little extra time at the end. We don't seem to have a full agenda, and I'm counting that'll be the case. And we might have some discussion of the mic from University of New Hampshire lab. There's something they are thinking of doing that concerns us, so it would be good to start the dialogue, at least have some awareness of what's going on. But that's the agenda. Other than that, we're going into the status. I believe Samita was going to go through this. Samita, are you online?
Hello? Can you hear me?
Yes, we can, and see you.
Okay. Hello, everyone. I'm also on the video. I don't know if you can see the video. On the
I'm sorry, could you say that again? You're where?
I am also on the video.
Yeah, we see you.
Oh, okay, great.
So do you want to go through these slides?
Sure. So let's go through the working group document status. We have done quite a bit of document progress this time. So we have DEC-TULE, which DEC-TULE 6 lowback, dispatch INR registry, privacy considerations are all of them on the IESG queue, submitted for IESG. And then we have 2 RFCs. So for DEC-TULE, as we know that we have gotten technical review from Pascal, and we also have got AD review and JNAT review from Joe Touch. It was waiting for AD follow-up, but in last couple of hours, I saw that it is on IETF last call. And then 6 lowback, which has gone through many reviews. Technical reviews were done by Tim Chon and Brian Haberman, and AD review from Suresh, transport area review by Joe Touch, and it's also on the last call. I have one slide from Kerry Lynn. He wanted, because it's past midnight, so he wanted me to go through his slide right after the status. And then dispatch INR registry, which was submitted to IESG. I believe it's in September, so it's on waiting on AD review, and it will go right after all these things are done. 6 low privacy considerations. It also went through interior review by Ioni Koronen and Jinmei Tatuya. It's also on the IETF last call. I believe there will be one slide, a little bit on details after this as well. And we listed Tero Kivinen's draft on the 802.15 IE. It is not part of 6-Law working group document, but it was sent to 6-Law working group for review. So if you have any comments, please provide. It's on IETF last call and Eddie sponsored. I see Pascal also is a reviewer for that, as well as I saw some comments from Charlie Perkins. Congratulations to the co-authors of 6-Law ether type request. It has become RFC 7973. Still on the editor queue, I believe, hasn't been published to the IETF list yet with the RFC number, but it's almost complete. And then 6-Law paging dispatch, congratulations as well. It's on the RFC editor queue. And the other working group sorry, any questions?
Sorry, I think Suresh had a question.
Yeah, no, I have some more info. So the deck ULE is now in IETF last call as well as of today.
Right,
So I requested a last call. So it's a longer last call for the IETF week. And ether type request, so it's been stuck in there for a while, right? It's been RFC at queue, it was done like almost 2 months ago. And what had happened was like we were waiting on a ether type request from IEEE. So we didn't want to publish the document before we got the ether type request. So the ether type request came through and we made some text changes to the thing, and it's an auth48, so it should be done anytime now. We are waiting for IANA to record the registration. So it's not an IANA allocation per se, but IANA records like ether types given to IETF. So once that is confirmed, this is going to be done. So it's an auth48, it's ready to go.
Almost
Thank you, Suresh.
So next slide, I guess.
Okay. So these are the other working group documents. 6-Law backbone router is waiting for the RFC 6775 update document to become working group document, and then it will progress parallelly. That is the plan. And then mesh link establishment. We need some update on this document. It hasn't been updated since the last IETF. We are going to talk. There will be a presentation on 6-Law NFC. And then recently we adopted
Sorry.
3 new documents.
Sorry, Samita.
Sorry.
Samita. On the mesh link establishment, so I spoke with Subir this week. So we're still waiting on a change on modification due to comments received on that document, on the base MLE document, as well as on the HipTex document. Once that happens, then we should be ready to go to working group last call, and eventually ISG maybe by next IETF. That might be a good target.
Good news. Yeah, thanks. So newly adopted documents, there is 3 of them: BLE mesh, 6-Law use cases, and 6-Law APND. I believe BLE mesh and APND also have been submitted as working group documents in last couple of days. And 6-Law use cases will be submitted as a working group document soon.
Yeah. Okay. Next slide, I guess.
So the 6-Law back status. The slide has been prepared by Kerry Lynn, and there's a little bit more details of the changes in version 06. As we already mentioned that it is at the IESG last call. And the major changes are like clarifying comments and the terminologies. Also, there is a change in section 3. I believe it was masked for IPv6 multicast Originally, it was masked that IPv6 multicast packet must be broadcast because the MSTP network does not support multicast. So, but then it was changed to should. Now it was changed back to must because of the inter-area reviews and based on some of the comments discussed back in the working group some time ago. So the line is IPv6 multicast package should be broadcast at the MAC layer and filtered at the IPv6 layer. That was changed to must from should. And then the comment was that explicitly state that all nodes must support RFC 6282 type of header compression, and he made that clarification. Also added a reference to the privacy considerations document. So yeah, that's it. Thank you. Any questions? Okay.
I changed the slide on you already.
Oh, that's for me as well.
Oh, okay. I can talk to that one. So the privacy considerations is also in IETF last call. There were not major comments, but some mostly editorial comments as part of interior review. We call them NITs, and those were addressed. So that's what we're now in last calling. And I guess that's it.
Gabriel, this is Dave Taylor.
Yep.
So I just wanted to call the people's attention. I think I posted this on a list, but the only one of the editorial comments that was not acted on was a maybe point, which was a bunch of the points in the document are not necessarily specific to 6LoW, even though it's a product of 6LoW. And the suggestion was, well, maybe it should have a more generic title. That's the only one that we didn't do anything because this is a consensus of this group, and it does have some 6LoW specific stuff in some sections. And so if anybody feels strongly, then we could possibly change that. But since the reviewer that mentioned that didn't feel strongly, and it was a product of this, that's the only one that I chose not to do. And so I've mentioned that in the list before, but just calling that to your attention right now.
Okay. So next, IPv6 over NFC.
Thank you. My name is Yonghwan Choi. This is the IPv6 over NFC. Next slide, please. This is the quick introduction about the NFC technology. Next slide, please. Actually, this is the history. It is the fifth revision of the IPv6 over NFC. They have two feedback from the NFC forum and Dave Steller. Next slide. The first one is the first change is the resolution about the feedback of NFC forum. Actually, they said it requires clear separation between the generation of IPv6 relative information and the other one, and the mapping of IPv6 information into LLCP PDUs. Actually, the first one is the main of the document, but the second one, actually, this document does not give any information to and mapping into the LLCP and PDU stuff. So actually, this first one is resolved, and the second is the document has repeated the structure information of the LLCP specification. So I just deleted all of them. it includes the PDU format and the extension option format. And the third one is this document used the DSAP and SSAP, which are the kind of address of the L2 of NFC technology. But there was some wrong information about the address, the SSAP and DSSAP format, and something the missed information in there. So I just revised all the text according to the spec, the LRCP 1.3. This is the latest version. The next slide, please. The next one is the MTU extension of the NFC link. They said actually the NFC MTU extension is not assume that the current devices support the link of MIU size of 2080 byte of IPv6 packet. But maybe some device, if some device NFC devices does not support the MTU extension, maybe they use the default size of the default MTU size 128. That means according to the RFC 9499 fragmentation. But if the device is extensive, the MIUX format could be used, will be used, and the FAR, it means fragmentation and reassembly is not required actually. So I just put that sentence, but there's some error, the grammar error. And the last one is the is about the example of the topology and application of in the document. Actually, section 5.2 said 3 or more devices can be touched to play the multi-channel music in there, but actually they said it's not practical, but I think they think only direct communication between two NFC devices. So they don't think of the multiple forwarding or something, multi-hop forwarding. So they think it could not be practical, but this is possible. Example in IPv6 over NFC. So thus I did not delete all of them. Just I revised some text. Next slide. Next slide, please.
I think that's it. Oh, sorry.
This is the last comment from the David Della. I know Dave spent a lot of time for review of my document, so I have to say thank you again. Actually, almost all comments are editorial and related to grammar, so all comments are reflected, but there are some issue about the IID generation. Actually, the NFC link used the 6-bit link node ID. That means it could be attacked. It could be a target from the attack. It's actually, this is true. I just agree with his comment. So I change the figure 3, the format of the IID. I just put the R bit instead of the 0. It means the red line is put it newly. Actually, the R bits are random values, which may be created by mechanisms like hash function with the SSAP as an input value. Because the 6-bit address of SSAP is easy and short to be targeted by the attacks of the third parties. For example, the address scanning. So I just put that. And there's another issued about the same IID lasting in multi-touch. Actually, NFC link use the SSL address from the logical value. So this is a temporal value. So actually, it is not true the same IID lasting in multi-touch. So there's no change of that. But next slide, just you can give me the comment.
Can you go back to the slide that we were just talking about? Okay, this is Dave Taylor. So there's still a potential issue with the red text down below, if I understand your intent, but thank you for addressing other things. And that is because it's a may use the term random, that means that the recipient side doesn't know what the address is going to be without using the context, which means you can't compress it as much, right? If you specified, here are the inputs, which are known to both sides, and here is the hash function, then it is not random, it's just a hash that is uniformly spread out, and it's a hash over something only 2 endpoints use, and that means you can get full compression. And so right now, this is not as optimal as it could be, and what the privacy considerations document was suggesting was you can still get full compression elision as long as you have a well-defined hash function. And so I guess that would be my suggestion, which is rather than making this be a may and mechanisms like, right, pick a specific hash function, pick the specific inputs, make sure that one of the inputs is something that is a value that is only known to the 2 endpoints and not to some like off-link entity. And then you can get full compression and elision because you don't need a context.
Thank you for comment. Maybe your comment will be reflected in the next version. And I hope actually I put the R bit after the FFFD, but I would like to put all of the R bit instead of 0 bit. What to think about that?
Yes, other than the little thing with a U in it, all the zeros and ones, basically you can use every other bit besides, I think, one of them. When addressing my comment, if you choose to do the better compression stuff, then you might choose a label like H instead of R because it's technically not random, it's just a hash or something to make it clear that it's not random per se. But yes, you should be able to use everything, but I think the U.
Okay, thank you. The next slide, please. Actually, this is the last slide. Actually, this is the status, the technical review between the NF forum and about this.
I just wanted to ask, I had a question for Dave, Suresh Krishnan. So how do you expect the shared secret, for lack of a better word, like the provision? Do you think they should talk about it here? Like how do they, 2 pieces like come to have the same seed?
I'm saying the NFC protocol itself does something. Your input should be based on something that is already provided by NFC. You shouldn't have to invent something new. Okay. So, for example, if this was talking about a different technology that used a shared secret that was provisioned, right? Now, I don't know if that applies to NFC because I don't know the details of the NFC spec, right? Then you'd base it off of the shared secret. If it was done as a nonce exchange at the time that the link comes up, for example, such that both ends then know, but somebody that's off-link doesn't, right? And then you can then compress because you have something that was established at link establishment time that uses your input. I don't care which, because I don't know the NFC protocol to see what's available. I'm just giving the feedback that says, hopefully if there is something, then you can use it. If not, then we can talk about that because I'm not the NFC expert, right? These guys are, so.
Yeah. Thank you. So my question is there something like this that exists? Is there some? Okay.
This is the last slide about the status of the previous one. Technical review about from the NFA forum. Actually, I request again the discussion result the August this year, and then I finally received the feedback from the NFC forum, and I reflect all of the feedback, but there's no comment so far. That's all. Thank you. Next slide, please. This is the last one. Just any question and comment, please.
Pascal Thubert, I'd like to understand what that means that there was no comment. And does it mean that in the next specification of the NFC, there will be a mention of IPv6 and it will be mandated in the devices?
You know, as you know, there's no liaison process between the IETF and the NFC forum. It's difficult to give, receive their feedback, and I just return back, give them back the resolution about this kind of process is not really easy. So I will ask another comment for this last version. But this is not done, but I will.
But ultimately, you expect that the NFC forum will produce specifications which include this work as part of their main specification?
I'm not sure about they're they'll mention about just exactly the link layer, but just we deal with the upper layer, totally separated. So actually, you don't need to tell. Yeah, thank you.
But I mean, you have, sorry, I got to so, but you have received some comments from NFC, right? And they're reflected in this version. Yeah. Some comments. So
No, all of the comments.
yeah, but I'm a bit confused, but because you say no, no more
Actually,
comments. I got it. Okay.
Actually, I gave my resolution about the feedback to the NS forum back, but they don't any further comment.
So how many real round trips of information going back and forth? Only one piece of
Maybe I will ask another comment to NS forum, but they.
No, I'm not asking to ask again. I'm asking up to now, how many times has actual information come from the NFC forum? Once. Is that it? They evaluated and gave the
nearly half of a year, 6 months, or 6 months or more. Because they have board meeting, member meeting.
Oh no, but I was just asking how many times have they done it?
Just once.
Just once, okay.
Yeah.
But they've provided some good food. Okay, good. So yeah, that was one of the main, at least from a chair point of view, was one of the main issues I saw, that they should at least be aware. Now they've passed that bar. They're not just aware, they actually commented at least once. We may have more comments coming, so that's good. That's whether they adopt, that's a different thing. But at least with Bluetooth LE, we're doing something similar, right? Proceeding with the path of they being aware, dialogue open. They may not adopt or point at our stuff, but at least there's no collisions or anything. Okay, that's good.
Thank you.
Now you did have a question about working with Lescal, and I think we just saw, at least from the compression of the difficult to scan, I don't want to say random addresses, but difficult to scan addresses. From that point of view, I think we may not quite be ready for that. So we at least need that revision. They have addressed that, but from the point of view of whether it's quite ready, I think that optimization is something that probably needs to be done. So that gives us actually a little bit more time. We may even get more info from NFC. I don't know, but we shouldn't wait on that. But the fact is, because of this revision, we may actually get more feedback from them. So I think we want to get that revision, and then we'll probably be ready. From Samita, any comments?
I have no comments now. I was wondering if anyone, I mean, I'm actually targeting this question to our AD, Suresh, if he has any suggestions, if we could approach NFC Forum and ask what's their standing on this document once we go forward, if that is an option.
That was a question for Suresh, right?
Yes.
Okay.
Suresh Krishnan. So I don't think we have a formal way of talking to them, but I can figure out like how to do that. Yes. Okay. So it might be like some common participant takes it there or whatever, but I don't want to make this too heavyweight to try to set up a relationship just for this. But yeah, I'll figure out something.
But personally, I'm encouraged by the fact that they've already acknowledged it and their official board meeting looked at it, provide feedback. So that's good.
Perfect.
Yeah, yeah, it won't stop us right now from moving forward.
Right. That's, yeah, exactly. Shouldn't be a gating item anymore. Okay.
Okay.
Thank
Thank you so much.
Next is, well, talking about Bluetooth LE. BTLE. Oh, shoot. What is Bluetooth LE? Oh, here we are. Okay. Catalyst.
Okay, good afternoon. My name is Carlos Gomez. I'm going to present the current status and last updates to the draft currently entitled IPv6 Mesh over Bluetooth Low Energy using IPSP. My co-authors are Syed Magdi Darudi, also from UPC and I2CAT like myself, and Teemu Savolainen from Nokia. Next, please. So first of all, let's take a look at the status of the document. Version 01 of the document in individual submission form was presented in Berlin. And the main comment received by this working group in Berlin was that it would be positive to contact. Okay. Okay, thanks. So the main comment was that it would be positive to contact the Bluetooth Special Interest Group in order to find out which is their opinion about this document, whether they have any concerns, and so on. So we did that, and we received some feedback from several people involved in the Bluetooth SIG. And based on that feedback, we submitted on the last day of October version 02 of the document in still its individual submission form. So shortly after, it was adopted as a working group document. By the way, thanks for the support. And the document, the content in this now initial working group document version is actually the same as in version 02 of the individual submission draft. Next, please. So let's talk about the feedback that we received from the Bluetooth SIG. Actually, we received quite some feedback from several people. This includes Mark Powell, who is Executive Director of Bluetooth SIG, and we'd like to thank the chairs for helping establishing the contact with Mark Powell. And also we received feedback from several other individuals also involved in Bluetooth SIG. So the good news is that there are apparently no major concerns. And as part of that, we have a confirmation that we don't need any new Bluetooth specifications in order to enable this specification. So we can just exploit, we can make use of existing Bluetooth specifications. So there was a comment which was made by several people that we should nevertheless avoid confusion with the Bluetooth Smart Mesh Working Group activity, which is happening within the Bluetooth Special Interest Group. And this includes two things. The first one is they suggested that we should avoid the Bluetooth Low Energy Mesh term. And on the other hand, they said that we should emphasize that we are using the IPSP. That stands for the Internet Protocol Support Profile. And that's a Bluetooth specification which enables a node to announce the fact that it's supporting IPv6. And it also enables another role of a device which is able to discover the support of IPv6 by a neighbor and allows to establish a link layer connection, which then will be used to enable the exchange of IPv6 packets. Actually, the IPSP is not something new in terms of the IETF work over Bluetooth Low Energy, because this was actually already required in RFC 7668, which specifies IPv6 over Bluetooth Low Energy in star topology networks. Next, please. So let's take a look at the updates made to the document. First of all, the title itself has changed as a result of the suggestions made by Bluetooth SIG people. So the old title was IPv6 over Bluetooth Low Energy Mesh Networks. And now the new title is IPv6 Mesh over Bluetooth Low Energy using IPSP. So on the other hand, also in the abstract, now we explicitly mention the fact that we are using IPSP. And in section 2, we already had some text explaining that we require IPSP and explaining a little bit some overview about this functionality. However, we have also added that forwarding devices, that would be routers, must implement the so-called IPSP node and router roles, while leaf-only nodes, that would be 6LNs, implement only the IPSP node role. The IPSP node role is the one which a device in this role advertises its support of IPv6, while a router is the one which, in addition to routing, would receive these advertisements. And the idea is that forwarding devices have to support both roles, because if a router wants to establish a link with another router, then it has to act also as a node that is announced that it supports IPv6. Next, please. Also, we have made several terminology updates throughout the whole document. That's because of the fact that we had to avoid using Bluetooth Low Energy Mesh term. So we've tried to more or less explain or express the same by using some alternative phrasing. And another comment we received was about the security considerations, where in addition to explaining that RFC 7668 security considerations apply, we also had some reference to RFC 7416, which provides useful guidance, because it explains possible threats and attacks and possible countermeasures when using the Ripple routing protocol. And we were asked to expand a little bit that text. So what we have done in this version is to at least enumerate which are those threats, attacks, and countermeasures that we could have. However, we think that probably it's not necessary to really expand that really further, because actually the details are already present in RFC 7416. And finally, we have performed also some minor editorial fixes throughout the document. Next, please. So now in this stage in which the document is already a working group document, we'd like to take the opportunity to also make a call to action. We'd like to ask people to read the document to make sure that the text, whether it's clear or not. And also we'd like to ask people to implement this draft specification, and it would be great to be able to perform experiments and validation of the content in this document. Next, please. Yeah, so that's the last slide.
Rahul Jadhav from Huawei. So my question is, clearly the capabilities, the mesh capabilities of a 802.15.4 network are different from the kind of capabilities which can be achieved from BLE mesh. For example, BLE mesh cannot support multicast. So there are some inherent limitations to what can be achieved. Does the draft warrant a section which can be dedicated to it and clearly explain what are the limitations and assumptions?
Well, there's already some text which explains that there's this limitation, the fact that Bluetooth Low Energy does not support multicast, So some upper layer multicast translates into several unicast transmissions. So maybe I agree that it might be useful to expand a little bit this section and try to explicitly state which may be the consequences of this.
Right.
Thank you.
Thank you.
Great call to action. Thank you for that. So people, please read, go ahead and play with it. Okay, thank you. Next, applicability in use cases. Hyung-gun, bring up your slides. Use cases.
Okay, thank you. Good afternoon. My name is Yonggun Hong. I'm working for ETRI. So I present the IPv6 6-row applicability and use cases. Next page, please. Yeah, it's the history and status. We discussed this issue from IETF 89. So there are some the history in during September 22nd and October 7th, we have the adoption call. So in this adoption call, we have several positive responses in support. So this is a 03 version. Next page, please. Okay, so I summarized the command in adoption call. So during adoption call, the command from Xavier, Samita, Rashid, Pascal, Jusang, Take, Diego, Paul. So thanks for your valuable comment. So among them, the Xavier says that he would like to see there are picture of 6-row, there are supported, and those there are not for the different underlying technologies. And Pascal suggests that we had better consider the TechNet use case document. It's a very good idea. So I refer in the next version. Next page, please. And also gave some comment. So he suggests that regarding 6-row PLC, so G3 PLC, prime, etc. So I'm talking to, I will talk to Take and make some the text poll regarding this. And he voluntarily suggests to add some text of the use case of MSTP and use case of LTMTC. And also Paul suggests that there is a more to add to the 15.4 than 60 sheet, for example, Y-Sun Alliance. So I will also handle this issue in the next version. Okay, next page, please. So in the current document, we are handling the 6-row link layer technology as like this. G-Wave, BLE, DECT, MSTP, NFC, LTMTC, also added to the 15.f. So we are handling many technology. So it is not easy to catch the correct information and the correct use cases. So we need more the command and input from each area expert. Next page. So to describe the applicability, we summarize the design space dimension as like this. As you can see, so the update firmware requirement is added in the last version. Next page. Okay, so this is the 6-row use cases. For example, in G-Wave cases, it can use as for the smart home. So, and the use case of VLE, it can use for smartphone-based interaction with the controlling devices. And use case of DECT VLE, it can be used for smart home. And for example, of NFC, it can use for alternative secure transfer, for example, in health cases. And also there are the use cases of LTMTC. Next page. Yes, this is the update from the last meeting. So in this 03 version, we update the introduction part. and we update the MSTP part in clause 3.4. We delete the late part of transmission of IPv6. And we update to 6-row design space dimension. We modify some explanation part of each space dimension. And we delete energy limitation space dimension because it is the overlap other design space dimension. And we add the update firmware requirement space dimension. And we update acknowledgement part. Next page, please. Yeah, it's the future work. So we also need the text, for example, the use case of MSTP. So I'm waiting from the Kerry, but I believe that he is very busy. So Kerry or the take an asset will provide the use case of MSTP more practically. And we refer to TechNet use case document. So we will consulting the how to the TechNet document solve this issue. And we have we must decide the LPWAN as a use case in this document because the LPWAN was started in the different working group. So in this document, how to handle the LPWAN, yeah, so we must decide, so it is our homework to do. And we must handle security consideration because if we describe security consideration, I guess that we can describe for each use cases or the general security consideration. So we will consider how to the best way to describe security consideration because in this document there are a couple of the different link technology are used. So it is not easy to catch the common the security consideration. So in this way, one of the alternative ways to describe the security consideration for each link technology or catch the common security consideration. And I think that the last work is from the comment from Samira. So she says that we had better add the tabular description for comparison of characteristic in terms of application on different L2 technology. So in the next version, we will reflect these works. Next page, please. Okay, so it is the next step. So after this meeting, we will submit the working group 00 document. Yeah, and I'm waiting your comment and your voluntary works to improve this work. So that's all. Thank you.
Thank you. Any comments?
Yes, I have a question, or question rather. So in the last slide, you have one line, yes, about LTE MTC. So do you remember if Take Unstood has committed to give you any example? Because I'm wondering, there is no, to my knowledge, correct me if I'm wrong, I don't know any implementations or any architectural going on 6LoWPAN on LTE MTC. But I think probably he mentioned that a scenario how we can run.
Okay, thank you. Paul, regarding the use case of LTE MTC, one of the authors in this document, the Dong Young Go, he's the works for SK Telecom in South Korea. So he wrote the text of this the LTE MTC use cases. So in Korea, SK Telecom, they launches the trial services IPv6 of LTE MTC, but I know that it is not the commercial service until now. So we, in the current status, there are some activity of IPv6 of the LTE-MTC. So I note that among the comment, there are some concern about that issue. So we will discuss about how to describe the IPv6 of LTE-MTC. So we need more work to solve that issue. Is okay?
I understood. I think we need to ask the working group, if we want to include just IPv6 over LTE-MTC here, or are we giving the scenario of using how to use 6LoWPAN? But we can leave that discussion maybe on the mailing list.
Yes, you're right. So, so we are not the expert for the link layer technology. So if you are the expert of each link layer technology, and if your company or if your organization have some use cases of IPv6 of that link layer technology, so let us know that let's to improve this document to include all the possible or some the valuables, the text for this document.
Okay.
Thank you.
Thank you. Next up, we have an update on 6LoWPAN ND. Pascal.
You have the controller.
Pascal Hubert. So I'm presenting today this update draft for 6LoWPAN ND. Next slide, please. So this work is actually mostly extracted from a workgroup document, which is the backbone router. A comment was made on the backbone router that it does really two things. It incorporates new capabilities for proxy operation of our backbone, but at the same time, it updates RFC 6775. So we decided to separate those two components and extract the update of RFC 6775. But then I did it as a personal submission, but don't be surprised that the text is already quite stable. So what we extracted from this update is actually blocking the progress on the 6LoWPAN backbone router draft, because what I intend to do is, as soon as this work is adopted, then I will clean up the backbone router draft for everything that is actually duplicated at this moment. What we actually do with this draft is solve the issues that we have documented in 6775 update request. The only chapter section in that draft that we have not actually solved with this draft is addressed by the AP ND draft, which was just passed to our group document like last week. So the main component that gets extracted from the backbone router is the operation of the arrow option. So the arrow option is now extended. We have a TID, which is like a sequence number, which allows us to, well, sequence the updates, and as we send them over a mesh, then we can tie that with the location of the device. And this TID was actually already present in the draft that we proposed at 6man, which is efficient MD. It's kind of the same features we have to care about here. And in turn, this update provides a function that is required by the backbone router, which comes from the fact that we don't register anymore the source address as we do in 6LoWPAN ND. Here we register the target address in DNS, and that makes the whole of a difference, because now we can do a proxy registration on behalf of a device. With the classical 6LoWPAN ND, you have to register yourself, and that's all you can do. Okay, so that's the main difference between this update and the original draft. So there was a number of issues actually associated with the fact that you had to register with the source address. This goes away with the fact that we support now the registration of the target. Next slide, please. So we published a 0.0 before the last IETF. And actually, I presented that the delta, and that was true at the time, that the delta was a kind of rewarding of the link model, which in my mind was a change on this link model. So we had a number of discussions with Eric, with Carsten, a number of people, Zach, and I think we agree now, and that's what the text says, that we don't actually change the link model. What we do is we refine the understanding of the consequences of the model we have. And part of those consequences, if you have a device which is in one network and there's a registration there with to register its link local address, and it moves to another network, it doesn't necessarily know that the 6 BBR is not the same, and that it's registering to a different place. What that really means is that its address is not protected in the new place if it doesn't try to register. And if it tries to register, it may face a duplication with the same address already registered in the new place. What that really tells us is that the value of the registration of a link local address all the way to the 6 BBR doesn't bring a lot of value. It kind of protects the link local address in a certain domain, but doesn't protect the device along the lifetime. So it's very hard to tie the kind of protection that you have with this registration. So what we say is, since we use the link local address only in the connection between the device and the 6LR, then it's enough to keep this registration inside the 6LR, and there is no point to do the DAR-DAC exchange between the 6LR and the 6 BBR, or the LBR. And really, that's actually saving a very weird process that we had. That we had to kind of, during the time of the registration of the link local, we had to keep this address in a separate neighbor cache. Because if there was a rejection, we could not actually place that address in the neighbor cache to send a reply back as an error. So we had to kind of store this address as being pending validation by the 6 BBR before we can use it. And we had to be able to use it for the particular response to the particular request, right? So that had a certain number of issues associated with that. So with the new model, we say, hey, no, since it's not so useful to go to the 6 LBR, you do the DAR-DAC, you don't do the DAR-DAC, you do the NSRO and NA-BAC immediately based on the information you have right now in your hand. You accept or you deny. If you have a duplication that's local, then you deny. If you don't have a problem with this address locally, that's enough. You can talk to this guy. And you use this link local to talk to this guy. For global addresses that will come later, you will use a link local address. So then again, you don't have to store an address in a separate cache, because you don't have to put this global address in your neighbor cache until you have accepted the registration. Before that, it's just something you store somewhere, but it's not changing your neighbor cache. Okay, so link local, you don't go to the 6 LBR anymore. Global, you use a link local to register, because now we don't register the source anymore. Remember, we are registering the target. So because we can register the target, the source can be a link local for a global address. And now you don't have to store it in your neighbor cache either. So all this kind of difficult process of maintaining a separate neighbor cache goes away. But it's really not a change in the link model, as I was hinting last time. It's more like a better understanding of the consequences of what we do. The global address has to be registered because it's part of a subnet. It can be validated as being unique inside this subnet because there's a prefix in it. If there is a 6 LBR responsible for this prefix, then you can write on this whiteboard and you know that you get your uniqueness and you'll be protected. For link local, you get none of that. So there's no point going to a 6 LBR. Okay. And that's pretty much it. So the biggest issue we had last time was this link model discussion that I think is solved by saying, hey, after all, we don't change it. After that, it's mostly the text which was originally in the backbone router, which was already workgroup document. And since this is holding the progress of the backbone router document, maybe it's time to adapt it. And that's it for me. Do we have questions?
Carsten Morman, so the assumption is that all this link local stuff happens with 64-bit addresses?
There is no assumption on what the link local is made of in this discussion. I'm not saying it's based on an L2 address, and anyway, we are not expecting that the L2 address is globally unique forever. We are just saying if you have a layer 2 address that you're going to use it to talk to this 6LR, well, you can use that in your link local address if you like. You don't have to, because now you will register your link local address anyway, and that's cheap because it won't go to the 6LBR.
Right. So what's the process you have in mind for getting a 16-bit address?
And that's done before you register the link local address, right?
Well, in 6LoWPAN, it's usually done when you register to the 6LBR.
The short address, you mean?
Yes.
Well, normally when you join this low power network without IP, you get that for your coordinator, right? So you can still get one for your coordinator.
Yeah, that assumes that you run the whole MAC thing.
But anyway, you can, if you want to use your global address, and if that's an implication of this, which I did not see, what's the problem? You can register the global address to your 6LBR.
Maybe I don't need an answer now. I just would like to make sure that we have a common model of how these 16-bit addresses are obtained. I mean, we will have another talk about that shortly. But the original idea was you get your 16-bit address through duplicate address detection.
So maybe that's something we have to revisit because it doesn't seem too logical to tie those two. But okay. I've not seen this impact.
James Woodyoung, Google. So I think one of the criticisms that I might have had about the original RFC 6775 was that it really is kind of a major extension of neighbor discovery. It adds address registration, duplicate address request and response, things like that. That's kind of not the way ordinary 6-man neighbor discovery works. This extended address registration option adds the ability to do proxies. And this draft is written as an update to something that was put forward and made into an RFC as kind of an update on 6-man's, I mean, this IPv6 standard neighbor discovery. And by the time you get to this ability to do proxy registrations, it's starting to really feel to me like this isn't anything like neighbor discovery anymore. And I wonder if it doesn't make more sense to present this as a whole new protocol that is not a flavor of neighbor discovery. Do
you think that is the time to make that change? That's what you have in mind? Because this is really not changing much of what we already have. So I understand more like making this decision like last time.
I know, but I read the draft before you presented it, and I was thinking about, so what if the draft says you can use this for 6 LBRs and 6 BBRs and the 6 low routers. There's nothing in the update or in the original RFC 6775 that precludes using this protocol in general for every IPv6 network, right? But if we did that, I mean, if we sort of said, yeah, this is neighbor discovery and everybody should be using address registration options and duplicate address requests on every IPv6 network, period, stop, because, simplify things, we'll just use one neighbor discovery protocol. And that's the one that 6LO came up with all of these address registration things. Now this is like becoming this really different philosophical thing. And I'm wondering if it really should be sort of narrowly said, this is for 6LO routers, not for anything other than 6LO routers.
Right now it's called 6LoWPAN-ND. That's one answer. Another, so it's not called ND, it's called 6LoWPAN-ND. And the other answer is we went to 6-man with this, pretty much.
Yeah, I remember that.
Under efficient ND. And so far we did not do much progress there. So
yeah, I know.
The specification is actually written as limited to 6LoWPAN.
Okay, maybe it might help to take some, invite some contributions from perhaps 6-man and 6LO to make it look more like it is, not just this tiny extension of neighbor discovery, and so that we can avoid.
Or we could work on adopting it at 6-man.
What did you say?
Or we could progress it at 6-man to generalize the use. I mean, it can coexist. I mean, the discussion, I don't think we proved that it could not coexist on the same network, right? So it doesn't, there is no blocking factor that we found that you could not use it on a classical network, right? So you're saying it's like you don't want it to happen, but
I think I would find that objectionable, actually. I don't really want address registration of this. I don't want this address registration mechanism being something that we have on every IPv6 network in the world.
Well, that's the 6-man debate, but that's worth debating.
It was debated. Are we still having that debate in 6-man? What? We haven't lately. Well, it seems like this draft is inviting that to happen again. And do we really want that? I guess I'll leave the mic and then come back later.
I just wanted I wanted to second that point. One philosophical question that we might want to ask ourselves is, if we sent this for review by 6-man, what is the answer we would get? And something might have changed in the meantime, but the answer that the efficient ND proposal got a while ago in 6-man was not on my network. I would second, and I know Eric behind me strongly disagrees with me, but I would second James. I do not want to see this on networks that are not constrained, because what this is doing is it's saying we have a power constraint and therefore we have to constrain addressing. Okay, and constraining addressing is giving up a lot of the benefits of IPv6, and so it's something that we have to do very carefully in a very scoped way. And so we should try to find, okay, I know you disagree, we've had this debate already, yeah, but let me finish. I think we should try to find a way to scope this such that both working groups are accepting of the outcome. What we don't want is to have work done in this working group that another working group that's actually authoritative for the IPv6 specifications doesn't like, and we have no sort of mediation there.
Well, I've not seen the poll about the doesn't like. I know you don't like. I know a few people don't like. We had 2 on this mic. I may find another 2 or 3 in this room.
I recall substantial opposition and certainly lack of consensus in adopting it.
Yes, the second one is agreed.
Okay, Carsten Bormann. So this thing has a long history. Yeah, maybe with new people coming in, it's good to repeat some of this history. So 6LoWPAN-ND was developed because ND Classic makes one basic assumption, which is that multicast is cheap. And there are networks where multicast is not cheap. So we developed 6LoWPAN-ND. We also looked at whether this actually would be a better solution for networks that do have cheap multicast, in particular once these networks get large. The problem with that is those networks usually already use ND Classic, so it's necessary to come up with a hybrid solution. And that's a bit more work. So I can imagine that people who already have a solution on a network where multicast is cheap don't want to do this additional work. I think that's a mistake, but we don't have to discuss this here because we generally work with networks where multicast is not cheap. So we did 6LoWPAN ND. And I really don't see any particular intent by the people here to conquer the rest of the world with this form of neighbor discovery. It's a solution that works very well for us. The solution that was tried to generalize. Now that may not go forward for reasons I don't agree with. But for our domain, where multicast is not cheap, we need a way to actually construct our networks without multicast. So yeah, I don't know what more to say.
And
I also
for all this, I
agree
agree
with
with
Carsten.
You on the queue? I'm sorry.
Go ahead.
Samita, do you want to
Carsten.
say something?
No, I just seconded Carsten's comments. And I think if this document is being used for the 6LoWPAN or 6Low related use cases, I do not see why we need to get blessings for generalized 6-man. So we have a particular problem and we are solving the particular problem using 6LoWPAN ND. And this document is trying to provide some extension or optimization for link layer address in the for the 6LR and the hosts. So this is not a usual scenario in the general 6-man case, general IPv6 case. So I don't see a conflict.
And if I may add, there is no constraint placed on the look and feel of the IP address that you register in this protocol. Right? There are other places where in 6LoWPAN where the IP address, there are consequences on the IP address, but not the registration protocol.
So Eric Nordmark, so I'm not a big fan of having non-technical discussions in the IETF, and this sort of notion of philosophy is something that doesn't make any sense because, you know, just because some people hate anything that looks like DHCPv6 and sort of bundle in address registration with that, that doesn't mean that they should be able to prevent anything in the IETF to do anything that does registrations. That's utter nonsense to me. If people have technical concerns about how this stuff is actually applied as an extension to or an evolution of 6775, that's fair game, right? But this other stuff that goes on in 6-man, I'm not a fan of because these protocols are products of the IETF. The IETF evolves them. Area directors and working groups figure out charters of who works on who, and the rest of it is just crap. So I'm actually quite fed up with that. So could we keep this a technical discussion, please?
Well, it's good. I believe it is in 6-man's charter to review things in other working groups that are bug. So you believe the arguments that James made were non-technical? Is that the arguments that he just came down to make? You think they're non-technical? So the concern that was raised in 6-man was about the limitation that it poses on the ability of hosts to form addresses autonomously, and that's something that we reaffirmed recently. And I'm sorry.
You can form whatever address you want. You can form as many as you want. The philosophical concern you have is that with DHCPv6 and with this, you're letting the router or the DHCPv6 server have a veto saying you can't get that address, or you can only get 3, or you can only get 0. That is your philosophical concern, right?
That's not philosophical. That's perfectly technical.
No, because it's a policy. If the router doesn't want to forward your packets, that's clearly bad for you, right? If it doesn't want to give you, if the DHCP server doesn't want to give you an address, it's clearly bad for you. But that's not a technical argument. It's about a tussle of between the operator of that router or server and you wanting to get service from it. How is that technical? We want to move the tussles out of the protocols, right? And provide people with different options. We have different options. You can go and allocate your own addresses and not register them, or you can go through DHCPv6, or you can do ARO in the case of 6LoWPAN.
So we do have a best practice that says that's a bad idea for networks to limit the number of addresses you have, right? And so, sorry? Right. No. Not so. The concern is that by making that easy is allowing a way to do this. That was the concern that was posed in 6man. Okay. So I don't. While I share James's concerns, I think if it's a link layer specific thing, that's fine. I wouldn't characterize the objections that 6man had to this as just not wanting to do the work, though. There were some other objections, which some may call technical, some may say or philosophical or religious or whatever, or arcane. Procedural. But there were other objections than just not doing the work. That's one thing I wanted to respond to your comment. It's a little bit harder to do if there are substantial semantic differences is how this operates today. And there's an increasing trend in not just 6man, but also v6ops about giving entire prefixes to hosts and doing, instead of registering individual addresses, registering prefixes. So that perhaps might be a better thing to do here in general. Now, again, this is a link layer specific thing. And, while I don't know what 6man's charter says at the moment, but that I think, personally, I think that's a better option. And maybe that's something that should be done instead.
Well, I would not compare the two, but if you really want to, and you say that we are depriving IPv6 from features, I mean, having to give a prefix per host is actually removing 64 bits of addressing from IPv6, so it also has some kind of drawbacks.
It is a best current practice of the IETF.
For general purposes, it doesn't apply here. That's the issue, right? It doesn't apply here. It does not apply here. Clearly, it's useful to be able to give out 64-bit prefixes to hosts that might have some set of devices hanging off of it, etc., right? And it gives some other scaling properties as well, right? But that doesn't mean that you would want to give that to the next trillion devices, right? Yeah, no, so.
No, I think like Suresh Krishnan, I think Eric made my point as well. So that's true for general purpose hosts, like who want to have more than one address, and they should not be deprived of like having the possibility of having it. But for a constrained device, like which may not need it, I don't think that applies.
Agreed. The way I interpreted James's concern was scope creep and extending the solution to other places. And maybe what he was saying is that if it expands further, he probably wouldn't agree with it. I don't know, maybe I'll let him say that.
So that we don't have to rely on Lorenzo reinterpreting what I said. Yeah, my concern is scope creep. Sure, I'll admit that perhaps my concern may not seem as technical as procedural, but I think that there is definitely a technical consideration in my head here. I think that, for example, when you add a bunch of new ICMP type code numbers to the IANA registries for ICMP that are specific to 6LoWPAN ND, and you say that they are used in ND messages, I think that kind of invites people to think about, well, what happens if we put these type codes and these options that are defined for 6LoWPAN ND? What if we put them inside ND messages that aren't inside a 6LoWPAN frame?
That's probably a good question.
Right, and I think that as soon as you do it that way, that's when you're inviting the need to have this stuff reviewed by 6man. Whereas if you repackaged all of this stuff so that the numbers didn't go into those IANA tables, and you instead picked your own tables that are just for 6Low routing and I don't know what we want to call it, like mesh discovery or something, whatever. Come up with a new name so that we stop distinguishing ND classic from ND 6-LoWPAN. We make this thing that's not ND, but it has this function, right? And then we don't have to ask for 6-man to review what we're doing. We can make up everything, but it's just for 6-LoWPAN. That might be procedural, but there's this technical aspect of which tables are we making adjustments on the numbers to.
Suresh Krishnan. So James, if I understand you correctly, you're saying like you want to subtype what we already got as allocations. Is that what you want really? Do you want to subtype the stuff that we already got as allocations? Is that what you're trending towards? Okay. But at some point, right? Like if you're extending ND, you're getting ND option space, and 6-man has to review. Mm-hmm. Okay. Okay, makes sense. I at least understand what you say. Thanks. Okay, so right, like so. Okay, wait, like I'll just repeat what he said and then we can discuss it, right? So James wants to fork the space from classic ND and 6-LoWPAN ND and make these developments on the 6-LoWPAN ND fork.
Right.
I'm just repeating what he said. Okay.
Yeah.
So does that mean that we should no longer use whatever it is ICMP type 130 through 134 or whatever the numbers are, and use different numbers, or for the options only? Still use the neighbor solicitations and neighbor advertisements and have different options code for ND in a different table? I didn't quite understand where you wanted the fork.
I think I would like to say we take all of the 6-LoWPAN, we take all of the tables, the IANA tables that reference neighbor discovery codes, options types, all of that stuff. We make new ones that are just for 6-LoWPAN ND, and then they include the things for 6-LoWPAN
With the same
ND.
numbers, yeah?
With the same numbers,
yeah.
Sure, but just different registries.
But the numbers have to be unique, because as things evolve, we might want to use DNS, whatever it's called, the RDNS option with 6-LoWPAN, right? So that the numbers already exist, but they're effectively, one implementation needs to be able to handle both for current and future. You want to have that ability there and not say, well, are we going to allocate number 37 to mean something different for classic ND and 6-LoWPAN ND? That would just be silly, right? So effectively, they are one table. They have a little thing on the right-hand corner saying, this comes from RFC 6775. So you can see where it applies. Is that not sufficient?
Well, I think that's what I'm saying you should do. If you
already did it.
So I think those people who like ND Classic so much should maybe read it. There is a section there which is called Introduction, and which nicely explains that what we have been doing about 8 years ago actually was exactly foreseen by the authors of 4861, because multicast is not cheap everywhere. So they allowed right in the spec to write specifications that replace the parts that rely on cheap multicast. And we did that, but 80% of the protocol is identical with classic ND. So it would be a much longer document if we had to repeat all that stuff in our version as well. So I think doing all this just to make a political statement about address registration is pretty weird.
This one.
So Lorenzo Colidi, so in addition to just forking the table as a technical implementation detail, instead of forking the tables, it's certainly possible to define a sub option which has 6-low option. It's a 6-low option container where the number space is entirely distinct, and that would not necessarily require 6-man review at all. And then you would then say if there was a common option that wanted to be pursued in as a sort of essentially for every IPv6 implementation that's not 6-low specific, then that could go to 6-man. And if it's something that's targeted for this increasingly different version of ND, then it could be in that sub-container. That's an implementation detail that's probably a little bit better than just forking the tables.
Okay, so Shushan, two things. Like first to answer Lorenzo, right? Like, so the overhead is like pretty important in this kind of networks, right? So if you go for an additional subtyping, that's like overhead. But I don't want to like talk about that. But I want to talk about the forking, right? I'm really opposed to forking off something without having a namespace to separate these two. Okay, so if you want to go down this path, like you need to probably get a new protocol number if you're going to like fork off the ICMPv6. Okay, so don't use 58, like use some other number. Okay, fight with IANA to get the numbers. But I don't want like somebody to squat on somebody else's code points.
Eric, not Mark. So Lorenzo, you said increasingly divergent, or whatever the words were, right? So the reason they're increasingly divergent is actually interesting, because when we went and did 67 and 75, right, we said, okay, here's a different environment. Let's go figure out how we can do things differently here. But then when we were done, we looked at it and said, oh, maybe some of this stuff we could actually fold back in, because some of it might be useful, right? Because some of these efficiencies might apply elsewhere. So can we make this stuff look more like one protocol as opposed to two variants of the same protocol? But that ran into some opposition. I think some of those people are here having the same debate today. And that was the philosophical opposition to having anything that looked like address registration, also known as DHCPv6, right? So the reason they're divergent is right here in the room. So if you want to fix that, there's a way of fixing it. But it's actually you that need to fix it, nobody else.
Okay. At this point, I'm not sure we can go forward yet with an adoption. I think we can. I hear some people concerned about scoping. I don't know if instead of scoping by creating yet another namespace, there's another way of scoping that would also satisfy those concerns. Maybe it's already in the draft. I haven't looked at, but
the point
it could be. You could just scope it in the sense that when does this apply? This applies to when multicast is expensive, or however you want to characterize it. Period, and don't oversell. And maybe that's okay. I think if we do that, we might still want to get review from 6man. We would filter that review, hopefully with AD support, by not accepting any of the philosophical arguments. But these are people who know ND. They might have some very good technical feedback as well. That's fine. But am I reading the room right, that there's some concerns about scoping?
Okay, so no, I don't think you are. The scoping discussion is already in this document, like it was in all the 6LoWPAN documents, right? It's a 6LoWPAN document. It's not a 6man document. It does not apply beyond. There is text about why it applies. So it does not apply where there is discussion about applying it, right? That's because that discussion, Lorenzo was already in this room 1 year ago about this and saying, oh, don't put that on my 6man network. And no, I did some sentences and say, okay, it's for those low power wireless things.
Okay. Yeah, I think I remember there's been this discussion before.
Yeah. They're all written in there.
Okay, so is that scoping fine for anybody who's concerned about?
And by the way, the other thing that I need to we are not adding or changing any option. We are changing the content of the other option, but we are not going to INR to register a new option or anything like that, right? We are changing a little bit the behavior of the other option that was specified in 6775. And we are saying, okay, with the new way, you register the target as opposed to the source. Man, I mean, why does this discussion impact the adoption of this document? And the scoping was there for since like 1 or 2 years ago when we did the background router work, right? I mean, that same discussion happened in that same room with the same people. So there's no point.
James Woodyard, Google. I see the language that's in the draft that says this is intended for these kinds of networks. I like seeing that. What I don't see is it is not intended for any of these others. I don't see it is actually not recommended
But
For anything other-
I won't be saying that because I'm not even looking at what it's not intended to land to the moon. But if somebody takes it to the moon, why not? I mean, it's not. It will be discussed on the Apollo mission. It won't be my discussion. I can say where it works. I can't say where it doesn't work. And actually, I don't agree that it doesn't work in the six-man land. But that's a discussion to have.
Well, actually, I haven't looked it up, Carsten Morman again. But I think we are quite explicit that the modifications to ND Classics that we specify have to be mandated by the specific IP over foo specification. So if you're not doing that, then I don't know how it would apply.
That's a very, very concise way of making it clear, actually, because Ethernet, for example, IPv6 or Ethernet does not mandate any of this. So in that definition, it would be completely out of scope. So.
Yeah, if we haven't made that sufficiently clear, then I completely agree with John that we should make that clearer.
There's another point. What to go back to the multicast is expensive. It's expensive everywhere, pretty much everywhere, except on satellites when it's cheaper, right? But in most networks today, it is more expensive. The question is, you make an engineering trade-off between paying that cost and the functionality you get out of it. And for a constrained device, that trade-off is very different than from a general purpose device. And you know, that's perfectly fine. And that's why we have different link layers and so on. Just wanted to say that it's not simply a question of whether it's expensive or not. It's just whether that trade-off is worth making in a particular let's call it application or whatever. Right?
But I think what Carsten was saying goes beyond the is it expensive or not. Actually, it doesn't even matter. The only thing that matters is, does the IP over foo have a dependency on this? Does it explicitly say use it? If yes, then it applies. If it doesn't, then it doesn't. Ethernet, for example, doesn't, right?
But
regular Wi-Fi doesn't.
But it's kind of buried in a bigger thing, right? I mean, I don't know what. Yeah.
So is there room to clarify those points, perhaps a subsequent message to the list, so we can just look at it before we actually have a call for
I think
adoption?
if we said it's not currently recommended on any other network at the moment, then maybe that, like James said, maybe that would help. I don't know. Then we could sort of re-examine it on different networks where it did make sense. I mean,
well, it will be studied by a network if that network wants to adopt it. As long as it's not adopted on this network, it's just not there. We can't recommend them to try it or not try it.
It's up to IP over foo to decide. I would
It's
say.
the other foo which has to come to us and say, yes, we want it, or we can work with them. But we don't know where it doesn't work. We have not tried.
That's, I think, what I would want. It does seem to need to be.
Hi, Bob Hinden. So let me look at this a little more pragmatically, I think. So right now on, I'll call them general purpose networks like Ethernet, we have two ways of doing address assignments, auto configuration and DHCP. If we start telling the world that now there's a third way of doing this, I think this is going to be very disruptive for deployment efforts. So while yes, it is possible to do this, I think it's a bad idea, and I think it's not going to help the overall deployment of IPv6, just the opposite.
So to that point, maybe this particular case of IP over foo is IP over or IPv6 over Ethernet, and that document doesn't recommend this, or that document could also say, please don't use it for that particular link layer, and that's fine. Or not, but that's not up to this working group. That's out of scope of this working group.
Okay, but again, I think if you look at this larger context, not whether it's technically possible or not, which it probably is, I think it's not a good idea for what we're all trying to accomplish.
But would it be within the scope of 6-man to say that, for example, say, please don't use this stuff for Ethernet or for quote unquote general link layers? And that might be within their scope to do that.
Yeah, we usually try to say what to do, not make a list of all the things you shouldn't do, but
because we've been asked to say what not to do here. So I'm thinking it's not our scope. Maybe it's somebody else's scope to say for this particular link layer, which we know because it's in our scope, don't do this. Maybe, I mean, it would be more in their scope than in ours to say don't do X for anything else.
Right. Yeah. I need to think about that. I'm not sure.
I'm having a hard time finding how to move forward and finding
is,
some consensus here.
I think it's not it would not be helpful for the overall effort to try to make this happen. Try to add a third kind of way of assigning addresses or
In general networks.
yeah.
Right.
Councilman, I'm sorry, there is no third kind. ND is an implementation that can be used for address auto-configuration, and it can be used for DHCP-v6. There is no third kind. I have no idea what you are talking about.
Yeah, that was my clarification as well. So this is a different form of doing duplicate address detection, as well as making sure your neighbor cache stays populated even when you're asleep, right? That's what this does. And you allocate the addresses exactly the same way as you do with 6-man IPv6, right? You can use DHCP-v6 if you want, or you can use Slack, right? You could use that using short addresses on some media that have them as an EUI64s. None of that stuff actually changes. And last time I checked, I believe that the 6-man working group seemed to have consensus to go solve a bunch of problems around duplicate address detection, because they came up with a list of about 10 of them. I haven't seen much motion in that working group to work on that yet. And that's partly tied up with this debate, right? But I think that the overall bit is that, no, this doesn't confuse IPv6, because it's just it's not a different address allocation. We have enough pain from having both DHCP-v6 and Slack already, but this doesn't make it any worse, as far as I can tell.
Suresh Krishnan, so, okay, Lorenzo, you want to use the mic?
No.
Okay, so.
That was long before your time.
Okay, so Suresh Krishnan, so the way I see it, okay, so not looking at high level stuff or whatever, right? Like ARO already exists, okay? So this is just trying to do new status codes for ARO. So whoever is using ARO can use these status codes, right? So we're not trying to get any new options or new ND stuff here, okay? So if something is broken, as people claim, it's already broken, not by this document, right? Because if you had a philosophical opposition to ARO, that time has passed, okay? It's fine to debate it right now, but this is not making a new ARO, it's just adding new status codes, pretty much. Is that a good summary?
I still don't see what prevents the adoption call.
I would actually like to get a hum going, just to get a feel of how things are playing out. So the question is very simple. If you agree that this document should be adopted, which does, of course, as a reminder, a document that gets adopted does not mean it gets published as is. It just becomes property of the working group and it will be modified, etc., as usual. So with that clarification, do you agree that this document should be adopted by the working group? If so, please hum now. If you do not think this document should be adopted, at least at this point, please hum now. So I heard hums for the yay, and I did not hear anything for the nay. Did anybody out in the audience hear anything for no's? I didn't hear anybody. So there seems to be some momentum to adopting it. Okay, so we can, okay, we'll issue the official call on the mailing list as usual. Thanks. Okay, well, who didn't say this was going to be entertaining? Now, next one, designating 6LBR for IID assignment, Rashid. And oh, Charlie actually is going to be the presenter, right? Right.
Well, I'll try a little bit anyway. Oh, how about that? Is that better? That's pretty good. All right. So I'm Charlie Perkins, and this is a report on some changes that have been made to the draft. There's not much technical modification, but there's some additional text that's in response to comments that we got from the last IETF and elsewhere. So next slide, please. So the basic idea is to use an algorithm that's shown in RFC 7217 to generate a new IID in case the 6-low node provides a identifier that it results in a collision. So the idea basically is that the router can do this work and be somehow more efficient and reduce time and energy that would be consumed by the node itself otherwise to generate a new, to try to avoid the duplicate address. So when duplicate addresses are detected, then we try to use some functionality in the router to actually do the work to help out the node. So in the second version, we actually did find a way to provide the answer back to the node in a more space efficient manner. Next slide, please. So here it is. This is just showing what RFC 7217 says to do. If you are going to do the random pseudo-random function calculation, then you put in the prefix and the network interface and the ID, and then there's this thing called the duplicate address counter, and then the secret key to generate a new interface ID. So you can run that from 72. This is, by the way, the node doesn't really care how the randomness is produced, but this is just shown from 7217 because it works and it does has some properties that I'll show in just a minute. Okay, so I guess that's basically it. Right, so then after you make the computation, you just make sure that it's unique before you send it back. All right, next slide, please. So here's a picture of there's an extended duplicate address request and a confirmation and an extended address registration option. So that we took 4 bits out of the reserve field there to have something called the cycle, which actually boils down to counting how many times you got a duplicate address. You want to avoid, you want to get something that's unique. And so basically, I think that's going to be very rare, but probably a good idea to have it just in case. So then in addition to that, since the device knows what its interface ID is that it's sent in, you can send back another set of bits for the address that would not, that you can go ahead and provide an address back to the node and have it not have to do the generation itself and come back to get the, and try again for a unique address. And we can just send that back by doing XOR with the ID that came in. And then, let's see, down there. Right, so I guess that's the same thing is happening down on the address registration option. Next slide, please. Okay. So in this version 2 that was just posted recently, as I mentioned before, you don't have to use 7217, but it is recommended. If you do use 7217, the same prefix and subnet would result in the same IID, but a different IID would always be generated when a different prefix is used. So that's part because of the parameters that are provided to RFC's, the pseudo-random function in RFC 7217. And if you increment the DAD counter, in other words, how many times the duplication was detected, then you get another unique address. Now, some of the comments we got before was basically, why do we need this? Because anyway, the chances of duplicate addresses are pretty rare. And so this may be solving a problem that people didn't see if it actually existed. So that was an excellent point. So we had to actually show why it matters. And so the considerations that we put into the draft basically are that the manufacturers may not be as random as you might like, and they might give some MAC addresses that are more likely to produce duplicate addresses. In other words, DAD would detect that there was a duplication. Plus, there are MAC addresses in various devices that are shorter than 64 bits, so you don't get so much randomization. And then finally, there's another perhaps minor effect that you might have some applications that really want to change the interface identifier much more frequently. Next slide, please. So this is perhaps a restatement of some of those same ideas that I've already said. So we do not want to have repeated cycles of duplicate address detection failure one time after another. We'd like to have I think there's several, in fact, even recent publications have said we really want to have opaque interface identifiers. We reduce the number of bits that are required to send back that generated ID back to the node. And I'm not exactly sure how expensive DHCP is, but I think it's pretty much more expensive in terms of time and processing requirement compared to the mechanism that's shown here, just calling the pseudo-random function. And then we actually do provide 64 bits of entropy as suggested. Next slide, please.
You have a question?
Charlie?
Oh, question, yes.
Michael Richardson. So at least in mesh networks, and the difficulty with DHCP is that if you try to use it as it is, the issue is that you're trying to multicast, and you're trying to multicast from an address that nobody knows where it is. So their link layer, they can't even reply easily because no one knows where it is because you don't have an address to put through your mesh network to tell people where you are. In Ethernet, that's all solved at layer 2 by the switches doing that for you with your layer 2 addresses. And so that's really that's not so much the cost or the bytes or that, it's that to make the DHCP v6 work before you've assigned yourself a global address is really difficult, okay? So it could be done. I mean, it's just that is some conniptions that you have to put yourself through to make that happen.
Simple matter of programming.
Yeah, it's just a simple matter of programming. That's right. Okay. It's just, I don't think anyone really wants to go that direction. But at the same time, people are using DHCP v6 to like this, to configure the multicast routing protocols parameters. That sounds like a bootstrapping problem, but it can be done concentrically. Right.
Well, but this is more than just a bootstrapping problem.
I'm saying they're using DHCP, which requires multicast to configure the multicast protocol.
Right.
Right.
Yes.
So that's okay because they can do it concentrically.
Right.
From the outside in.
And we've heard a lot about how multicast is not so good. But okay. But anyway, you're right. That's some good information we should add into this. Please.
Dave Taylor. I didn't understand one point, and I looked for the answer in the document, and I couldn't find the answer in the document. And so the question is, where does the 6LBR get the interface index from? If you go back like 2 slides or something like that, is the one that I was. Back one more.
That one, right.
That one might have your answer. I don't know. So on this one, this is just explaining what 7217 is, right? I'm just talking about net IFACE, which is the second argument there, and I'm trying to figure out in this proposal where does the 6LBR get that number from to fill into the algorithm. And I couldn't understand from this slide if it's getting it from someplace or what. And I looked in the document, and it just says it uses a public value for it, and I couldn't tell what that meant.
Okay, well, I don't have that picture here. It was actually in the previous presentation that we made, but really the node itself it sends in, and it tries to do a duplicate address detection on what it has for its interface identifier, and then that by the action of the network itself, it should get to the 6LBR, right? And then the LBR can do a generation of if that at the 6LBR it knows about the whether or not the duplicate address detection is going to fail, and if it sees that it's going to fail, then it can run this algorithm. Okay.
I'm still confused, but it might just be me. I thought you were saying the 6LBR is what's running the 7217 algorithm. Am I confused?
The only thing about 7217 is to show how to do the pseudo-random function. I'm not answering your question, am I?
No, but it might just be me. Okay, so let me phrase my question, and you can tell me to go away if I just completely misunderstood the draft, and I'll go read the rest of it. I read parts of it looking for my answer.
Okay.
So I thought that you were saying that the node itself, that the 6LN, doesn't have to generate the IID if this is the mechanism.
No,
the 6LBR is generating the IID.
It does generate, it has an IID, and it tries to do duplicate address detection.
Right.
And only when the 6LBR realizes that that duplicate address detection is going to fail does it do this work.
Okay, so let me rephrase then okay, so you're saying the node, the 6LN constructs the IID itself, and if it would be a collision, then the 6LBR takes over and gives it a hint in some way.
Right.
Okay.
That's
and
it.
so in generating the second IID, right, which is the one that you want to make sure it succeeds, who's running the PRF function in that case?
The 6LBR.
The 6LBR. Okay, so if the 6LBR runs that function, in order it has to have the inputs. Okay, so it obviously has the prefix and the network ID because it's kind of authoritative for those, but it's not authoritative for net IFACE. So how does the 6LBR get that? Because I'm trying to figure out, is that in some packet that is sent from the 6LN to 6LBR? Because the 6LBR can't run the PRF function if it doesn't have the inputs. Am I confused?
No, you're not confused.
Okay. Did you understand at least Michael understood my question, so.
I think you are sign define one.
I think I know.
It's what?
Number sign define one.
Number sign define.
It's going to be a constant.
But there's a reason why it's in the PRF.
On the
Okay,
client.
on the client.
The
Okay.
client knows that he has multiple interfaces.
Correct, right. So I'm just going to repeat what Michael said, which is correct. That's why it's in there, right? Which is it's in the PRF because if there's a case where the client has multiple interfaces, he needs to get a different IID on the two interfaces connected to the same network because all the other values are identical across the two interfaces. Okay, so that means you either need to constrain it to say, well, the following mechanism will only work if you have one, or you need an alternate, or you need a way of passing it, or you need an alternate solution to constructing the PRF, right? One of those three things. And I'm just asking, which one is it?
Well, as far as I know, the only reason why we have it in there is because 7217 wants you to have it in there. Okay.
7217 has it in there for the exactly the case that Michael mentioned, which is if the node has two interfaces attached to the same network and needs to get two separate addresses, meaning two separate IIDs. Okay, and so since this is a hash function, there's no randomness in here, right? If both interfaces are attached to the same network, every other input is the same prefix, same network ID, same DAD counter, same secret key. Okay, so the only thing that differentiates the inputs is the network interface. Okay, and so that guarantees that they will generate different hash values for the very first time. Okay, so that's why it's in there to begin with. Okay, and so in this mechanism, if it hits it, then what does the 6LBR, how does he know what value to put in there, right? If he always puts in 1, that may still collide with the other one, and maybe you're saying, well, it's always 1, and then he just keeps revving the DAD counter or something, right? But right now, the draft doesn't contain text. That's actually the answer I was expecting, is you just keep revving the DEV counter, but that text is missing from the document right now, and that's the text that I would want to see. The point, my main feedback is the document doesn't contain a discussion of this, and it should. I'm not saying it's not solvable.
Excuse me, Dave, Rashid here. So the DAD counter, we included one sentence that if there is any kind of like collision, then DAD counter is going to help us out.
Doesn't say where it gets the interface index. Right now, the draft, unlike this slide talks about net IFAC, where it has a bunch of ORs in there, right? The draft right now says interface index, right? Meaning out of that list of ORs, the draft right now says we're going to use an interface index, and it doesn't say whose interface index or where it gets it from. And
But this is for the case when the node itself has multiple interfaces. Right. Okay. Yeah. All right.
Pascal, tu veux? Yes, that's actually a problem. Can you please go to the slide with the formats? You got the 4 bits type, there are options.
Right.
Yeah, I'm confused by 2 things. The first thing is when you say there are options between the 6LR and 6LN, well, the cycle has to be booked because if we need to express something between the 6LR and the 6LN, there is only one error option. And if the error option has to fly all the way, I mean, and by the way, the status is going back from 6LR, so it should be there as well. So if this is an extract from the document, it needs to be fixed in the document.
Well, I think that in order to, I think I would like to have included the slide that shows actually the control messages going back and forth to see how that goes.
But the format is not correct, what I'm saying. And I would book the cycle in the arrow regardless of where it is, because you block this on between the 6LR and 6LBR. So since we send the arrow all the way from the devices, now it's booked, kind of. You see what I mean? So it's very hard to say, I have a different arrow here and there. And by the way, the status is present in the arrow between the 6LR. You see this reserved piece that you have on the left? Actually, there is a status there. And it should be represented if that's your representation of this. And by the way, 4 bits is very heavy cost for this in this 8.
Well, I think you could probably get away with like 2 bits because it's only for a very rare case when you're sort of continually generating something that's going to have a collision.
And actually, where you placed it is colliding with the arrow option in the
Well, okay.
So Eric Nordmark, so I was browsing through the draft trying to find more about the motivation, because typically you never see any collisions because we have 62 bits of randomness when we do this. So is this because you're trying to constrain the IIDs to have a bunch of zeros in them, or are you having a network that has on the order of 2 to the power of 31 devices on it, a link?
Well, I think there are a lot of people who think that networks can become very large. I mean, for instance, it's not protocol related to this, but there was an effort in 82.15 for layer 2 routing, and they were talking about thousands and thousands of devices. Well, no, that's not 2 to the 31st, but it's a lot.
Because you get probability of half, birthday probability, right? 2 nodes will collide with the probability of half when you have 2 billion devices in this network. 2 billion is a fair bit. Even in the IoT estimate, sure, you will have that many on the planet, but not in a single network. So the reason I ask about the motivation is this seems like we're skirting into the territory that Bob was concerned about, which is we're inventing yet another address allocation mechanism, not a duplicate address checking mechanism. Because you're asking it to say, if this fails, please allocate one for me. And we haven't done that before. We've just said, check if this is a duplicate. Right?
Well, it is in a sense an address allocation mechanism, but it's not in any way constraining the address that you would get. It's just that you're providing a good capability for duplicate, avoiding duplicate addresses. And there is something, can you go back to go down to the next slide? No, keep going. Forward.
ARM has that today.
Well, keep going to the one, disadvantages. So, a previous one, I think.
Sure.
No, keep going. I'm sorry. Well, there was a discussion about, some ways that the randomness could be less than you would expect. For instance, if the manufacturers didn't play nice with their choices. This slide, yeah. And then there's something else, which is that if you can get the device to have an address sooner, then you would avoid some time delay too. You don't have to go back and forth to do the multiple.
Sure, but the probability of having to do it more than once is extremely small, right? With 62 bits of randomness, right? And
And actually,
Yeah, but you're not using the MAC address to generate this randomness, right? You can have MAC address collisions. We can't deal with that. That's the MAC layer's problem. But you're not using the MAC address as the main key. You have some set of randomness when you go and generate random addresses. And since even ARM has figured this out, that they need it for at least for security, right? They put hardware random generation into their even the low-end MCUs, right?
I don't think so. Not for all these IoT things. I mean, these are really extremely small devices in terms of functionality.
Which? No, but which?
PRF.
The PRF has a secret key. The secret key is unique per device. And if you have a hardware random number generator in your Cortex-M processor, that's good enough.
The goal is to have that number be the same across all power ons, because the idea is to have a stable address, right? So it's okay if you can say boot up, I have no secret key, I generate one and I save it, then I'm good, right? It's the save it part that I think is the skepticism.
But so initially, the first time this device is powered on, it generates uses a hardware number, random number generator to generate that secret key or whatever, okay? And that now gives you 62 bits of randomness, or is enough randomness to give you 62 bits of randomness in your IID, right? So then probability of collisions is extremely small unless you have billions of devices on your net. So that seems like we wouldn't need this, right? I mean, if you said that for whatever reason I want to do compression, right? So I want 8 bits of interface IDs and 56 bits of zeros. Sure, then we have a bit more of a challenge, right? But now your network is not going to be that big either. But if you want to compress the interface IDs to save bits in your compression, right? Yeah, then I could see that the motivation for this stuff. But no one has made that claim yet, so.
So we have to work harder to make a case for that this is needed. And
Lorenzo, could be an opposite question about why this is needed, in the sense that the way I read this is, hey network, I would like to use IID A, and the network says no, use IID B, right? So this is how it works. So at that point, given that the network has a much better source of randomness, a much better stable storage, a much better everything, why can't like the protocol be, hey, I want an IID, here you are, right? Because now we can't use DHCP because it doesn't work on non-multicast links, but this is what it is. So let's just make that all be zeros. We don't have to build any code and link these battery devices, and let's just say here's a bunch of zeros, and then here's your ID. Have a nice day. And then if you have stable storage, you have stable storage, and the network can store it, in the cloud, whatever, forever, right? So, right. So I don't see, because like you generate some randomness, but like not all the time, and so you have a bunch of complexity that you might as well not write the code for.
This is Tariq Serar. When you generate the IID through pseudo random number, there is possibly real chances of collision, but there is a possibility of collision after zoning it with the EUI64. For example, the random number generated is 1000, and the other node generated is 011. So similarly, if you swap both the IIDs with the EUIs of the two nodes and you XOR it, I guess you will get collision after that.
I'm sorry, but I didn't fully understand your question.
I'm saying that when you using the pseudo random numbers for the 64-bit IID, and then you are XORing it with the EUI64, is that I'm getting the right what you are showing in the slides? Oh. But I think with the zoning with the EUI64 address, you will get some collision.
With just using the EUI64 address, yes, you can get some collision. Okay.
I just calculated this, so that's why I'm questioning this.
It is unlikely. We agree on that. Okay, Karsten, a comment?
Yeah, Carsten Moning, and if you are looking for a reason to do all this, I thought the original reason why this kind of protocol was being discussed was the situation where you try to get a 16-bit address by registering the address that is derived from the 16-bit address using the algorithm somewhere. Now this works wonderfully if you just generate a random 16-bit address and try to register as long as you have your network less than, say, half full. So there are 2 to the power of 15 16-bit addresses for some reason. So as long as you stay below four digits, at 4 digits or below, then you're fine. But if your network is really filling up, then it's hard to get those 16-bit addresses because you have to do several attempts. And that was the original reason why I thought this kind of work was being done. But it seems that's no longer on your plan.
Well, I'm not quite sure what to say. I mean, there's I've heard opinions of 5 people or so that the chance of collision is so unlikely that there doesn't really need to be a mechanism to help out if there is a collision. But this is a mechanism that can do it, and if it avoids going back in and doing duplicate address detection multiple times, and that it can help with perhaps some time critical application. We can do the best we can to find out if there's a good use case for that, like we think that there is, and make additional documentation about that and discuss the issues. But other than that, I don't know what to say.
Yeah, so I think the one area of application I have in mind is the original 82.15.4 situation where it's nice to get a 16-bit address, and if your network grows beyond a couple thousand, then there actually is an appreciable collision probability. It doesn't make sense for MSTP because you need a MAC address to even send anything there in the first place. So in MSTP, you have to have another way to get your short address, but it doesn't make sense for 82.15.4 original. I don't think it makes any sense when you actually have 62 bits of entropy there.
Okay.
Question, like maybe I should have asked this. I probably should have asked it a long time ago. Why is it the XOR? And like what you return to the 6LN, right? There's the XOR of the UI64. Why can't doesn't the 6LN know its own UI64? I think it's in the next slide, perhaps. Like what you return, right?
Well, if you're going to generate a new one and the device knows what it is, then you can use this XOR function to avoid retransmitting both of them coming back.
Right, but the UI64 hasn't changed. You said is that UI64 like literally the node's address? Is there nothing else in this packet?
Well, the original problem that we had when we tried to do duplicate address detection in 6LoWPAN-NT was that since most nodes are sleeping, we can't really find out whether other nodes are there that are the same or different. To find out whether another registration is actually coming from the same node as the original registration, you look at the EUI64 that is sent with the registration. So the MAC address is not bound to the EUI64. You can register any MAC address you want, but to find out who is registering that, whether that's the same guy just re-registering at a different router, or a different guy who tries to steal your address, we send the EUI64 of the node together with the registration. So that's the reason why this.
The one on the left, yes. And the one on the right, like anyone could like on the one on the right, if the UI64 is the identifier of who you're sending it to, then some random node might might go to some other random node. I'm talking about the packet on the top right. If that packet goes only to the node that requested it.
I don't know anything.
Folks, I think we should probably take this offline. We have 2 more presentations, and we're starting to run up against time.
Okay.
I think you're next up, Charlie, right?
I am.
If you could, let me see, let me get your presentation up.
But I would like to actually follow up and try to answer the question.
Expiration time, right? That one?
Okay, so this is a new draft. I'll try to make it more quick. Next slide, please. So the idea is to try to provide some way to enable delay-sensitive applications. And actually, I was not involved with this draft until just a few weeks ago. But apparently it has some history with discussion on the mailing list in 6TiSCH. And so if you look at the presentation, you can see some of the discussion from the mailing list. And there's also interest from this other draft that has to do with transmitting OEM information between networks. And you'll see why that is of interest to the authors of the OEM draft in a few minutes. So we think that this draft could be should be worked here in 6LO, but it also could be of interest in 6TiSCH and roll, and perhaps .NET also, or more likely .NET. Next slide, please. So basically, the idea is that first of all, this applies most easily for time synchronized networks. It's pretty straightforward in that case, and you just put in, since you have time synchronization, the device, when it sends out the packet, it includes the current time, includes expiration time as part of the 6LO, a new 6LO header. So that, since you have synchronization, then when the packet is delivered to the destination can actually see whether or not the expiration time has been reached, and then drop the packet if need be. And the same thing is true for intermediate nodes that see that expiration time. So next slide, please. So here's just a picture of proposed format. So this uses the 1.0 page for the timestamp format, and then that X bit is set to be 1, so it can be it's an elective header, and then there's a D bit that's we can set that bit because it depends upon the header type, which is to be determined, but it's the one for this timestamp. And then the main part of the payload has to do with the expiration time in microseconds, and the expiration time and the size of that is determined by those 4 bits of size in octets there. So there's a way of computing the packet origination time that, in other words, you can tell if the expiration time has been deleted by subtracting off this packet origination time that's computed in a way for 6TiSCH networks as shown. Next slide, please. So if if the sender and receiver are in the same network, then this, I guess, is showing the non-storing case. Then by the way, I have not. I need to read this use of RPL info text, but basically the idea is that if you have to use some encapsulation, then you put the 6LO RH header in the outer header, and then it goes up to the 6LBR and goes down to the receiver, which can then detect whether or not the expiration time has been exceeded. And when the 6LBR forwards it to the receiver, then it copies information out to the outer header as well. Next slide, please. So if you have two networks that are also time synchronized, then you can use basically exactly the same idea. And there's the one difference is that if you want to go between the networks, then you can use this idea from the OAM draft from Brockner's, et cetera, to do the include the expiration time as one of these edge-to-edge options. And so then other than that, it's exactly the same kind of computation that you can determine what is the origination time since it's synchronized across the networks. Next slide, please. And finally, I think this is actually exactly the same computation. I don't think there's much difference involved with that. But well, I'll take that back. There is the difference is that the networks internally are synchronized, but they don't actually have the same time between the two networks. So in order for this to work, the two 6LBRs at the top have to know what is the time difference in the synchronization between the two networks. And so basically, for instance, the one on the left has an idea of time for its southbound interface, and it has a different idea of time for the lateral interface to the network on the right. So it has to keep track of what is the difference in time between the two different synchronized networks. But with that distinction, it then can make the simple computation to determine whether or not the expiration time has been exceeded. Next slide. That's it. So again, this is a brand new draft, still being developed. But if there's interest, and I think there could be quite useful, then we will would like to continue on with this. Yes, comment, Thomas.
Thomas Otena, I have a clarifying question, a remark. Clarifying question. You seem to always say that the packet reaches the receiver, which then drops it. Does the draft not consider dropping it as it's being forwarded? Just
yes, you should be. In fact,
sorry, I didn't read the draft,
right.
Which is obvious. Yeah.
So in the draft, it does say that if an intermediate node should drop the packet if it's already.
So as it goes from S to R, at one of these 6LRs can be dropped if it's past deadline. Second remark is dropping a packet because it's too late is a binary decision. It might also be interesting. I'm thinking about control loops to know how long it has been. So not just a deadline, but also I sent it at this date, and drop it if it passes this date, so that when you receive it before the deadline, you might still be very interested in knowing how long did it take to transition over your network. Is that something you have considered?
So you're saying that if it's still delivered, even though it hasn't expired, you'd still like to know for perhaps measurement purposes or just some sort of jitter estimation or whatever, exactly how much of the time, how long it took.
Imagine there's a sensor that measures an angle and that is transferred to a actuator that corrects the angle, and the thing is falling over. So if that measurement comes very fast, you know that it's probably close. If it's come very late, you know it's probably almost fallen over.
Yeah, we have that's a good idea. Actually, I like that, and so I don't see any reason why. I mean, if we have information, we should allow the use of it. Absolutely.
Okay. Could you keep it very brief because we have one more and we're running out of time.
Okay, actually I had two things, so one of them maybe I can take to the list or offline. Well, one quick thing was on slide 4. If you can go back. So the elective, you're picking a elective header. If you're doing that, then you have to put the size in the 5 bits. You can't use a bit, because elective means I don't have to understand it. If I don't understand it, I can skip it. If I can skip it, I have to have the size that I need to skip. So you can't steal a bit from an elective. It has to be a size. So either you make it critical and then you're okay. You can do whatever you like.
So are you suggesting that you are not allowed to use best effort forwarding if you've already exceeded the expiration time?
No, that's a completely different topic. It has to do with the fact that elective means if it's a header that you can ignore. It just means you don't understand it, but you can ignore, skip it, forget it. Don't make as if it was not there. But to do that, you need to know its size because you're skipping it. So we force that the 5 bits after 101 are the size because that's what you skip if you don't understand it. Right? So you can't modify the size at that place. You can modify the TSC, right? If it is, right? Well,
okay.
That's a fact of life.
I'll think about that.
Yes.
The next one, please, offline, because we have 5 minutes
Thank you
and
very
Carlos
much.
still has to present. Okay. Okay.
Okay, so I'm going to present the draft entitled Optimized 6-LoWPAN Fragmentation Header. And well, there's a little bit of context here. Those of you who may have been following the LP1 activity will be already familiar with this work. The point is that originally this work was done originally motivated by the requirements of some LP1 technologies with some really constrained layer 2 MTU. And in addition, these technologies, some of these don't support link layer fragmentation. And we found that the original 6-LoWPAN fragmentation header was not suitable, incurring high overhead, or even in some cases, it's not really possible to use it to enable the IPv6 MTU requirement over these technologies. So that's why we developed a more lightweight fragmentation header. And in Berlin, in the LP1 working group meeting, we presented this version 02 of the LP1 fragmentation document. And there was 2 comments here. One was that for LP1, we should explore a even more lightweight format. And the other comment was that this exact same format could be considered by the 6-LoW working group since it is using the 6-LoWPAN dispatch field, and it's using 6-LoWPAN dispatch values which are currently available. So this document here is presenting the same fragmentation header format as in the version 02 of the LP1 document, however, with a generic motivation which is not specific for LP1 and some updated performance analysis in the annex. So the original 6-LoWPAN fragmentation header was designed to support the IPv6 MTU requirement over 15.4 links, which have a frame size of only 127 bytes. So this fragmentation header comprised a 4-byte header for the first fragment, a 5-byte header for subsequent fragments. However, in this document, we are proposing what we call optimized 6-LoWPAN fragmentation header, which has a 3-byte header format for all fragments. And the main advantage here is lower overhead. However, there's some additional advantage in the fact that it supports very constrained technologies, even with very short layer 2 MTUs, such as only 4 bytes in the most extreme case. So this is the format. For the first fragment, we have a 5-bit dispatch type value, which indicates that this is a first fragment. Then we have an 11-bit datagram size field, which encodes the original IPv6 datagram size. And then a 1-byte datagram tag, which identifies the original IPv6 packet. For subsequent fragments, we have also a 5-bit dispatch value, which indicates that this is a fragment, but not the first one. Then a datagram offset, which has a size of 11 bits. This allows to express the offset of the data being carried in the fragment in increments of 1 byte. and also the datagram tag as in the first fragment format. Next, please. So, which have been the changes in comparison with the original RC 4944 6-LoWPAN fragmentation header? The datagram size field is now in this format only included in the first fragment. Originally, 6-LoWPAN defined this fragmentation header where datagram size was included in all fragments in order to help the receiver in the task of reassembly, since fragments could travel through different paths in a 15.4 network. So reordering was relatively likely. However, the format we are proposing here is still supporting reordering, even if with a little bit more complexity for the receiver in this case. The datagram tag field size has been reduced from 2 bytes to 1 byte. This is because we understand that ambiguities due to wrapping of this field are really not expected, considering that most applications here will be using a relatively low message rate. And finally, the datagram offset has been increased from 8 bits to 11 bits to allow expressing the offset in 1 byte increments. Next, please. So this optimized 6-LoWPAN fragmentation header supports, well, it's a simple byte exact and short format, which also supports maximum layer 2 payloads of only 4 bytes in the most extreme case. And it offers an overhead decrease, which is significant. Here we have a study which is found in the annex of the document, where we compute which is the overhead in terms of adaptation layer fragmentation header bytes in order to carry an IPv6 datagram of one of these sizes considered in the table over link layer payload, which varies from 10 to 100 bytes here. Next, please. So we need to allocate 16 dispatch values. The first 8 ones correspond to the dispatch value used for the first fragment. The other ones correspond to subsequent fragments. We also have the security considerations here. And in fact, 6-LoWPAN fragmentation attacks and how to mitigate them has been considered in the literature. So, for example, there's a buffer reservation DOS attack, where an attacker sends a first fragment to a target and then occupies the reassembly buffer during the whole reassembly timeout, so that legitimate fragments are not accepted by the receiver for that buffer. And the attacker can just repeat the same operation after the timeout. So this is actually a quite low-cost attack, which is linear with the number of reassembly buffers that the receiver has. So mitigation would be trying to increase the cost for the attacker, for example, by allowing fragments of multiple packets in the same reassembly buffer. And if there's some buffer overload, then some packets could be discarded based on analyzing the sender behavior. Next, please. Another attack is sending spoof duplicates. In this case, the malicious node is required to have overhearing capabilities. The attacker may overhear a fragment and may send a spoof duplicate, for example, with some random payload. And then the receiver cannot really distinguish whether a fragment is legitimate or not. So this ends up with the original IPv6 packet being considered corrupt and finally dropped. Some mitigation has been suggested in the literature, such as establishing some form of binding between the fragments to be sent, so that the receiver can distinguish illegitimate fragments. Next, please. And finally, implementers should avoid problems due to intentional or unintentional transmission, for example, of overlap fragments, and also an event like a first fragment announcing a fake datagram size. Next, please. Yeah, so questions, and actually I'd like to ask to the working group whether you think that this is something interesting for this group.
Carsten Bormann, I think this is really great work. The one question we probably have to ask us is this worth 16 dispatch codes? I also have a small problem with the title. because it's the second optimized fragment format. The first fragment format already also was optimized, just was optimized for a different set of assumptions. So maybe finding a different term that says something like low speed or that might be more appropriate here. The fundamental problem, of course, is this creates an option. This makes life harder for implementers because they have to decide which of these they want to implement. And if you have two implementations, one of them implements one and the other implements the other, they can't interoperate and so on. So there is a certain cost to doing this. 16 dispatch codes, less interoperability. Do we want to do this? I think we should look very closely at the use cases.
Pascal Hubert, I'm more than happy to revisit the fragment work. It's been something we've been trying for a while. As we do that, I would suggest that we look at the big picture of what exactly the problems are with the existing fragment, where I think it's more important to look at this big picture than just save one bit here and there. And the big picture says, when you lose one fragment, what do you do? Right? The devices today, they wait for like a second, and when they have only one receive buffer, they can't receive any more packet for that second. That's a real life problem about fragments. That's one of those things, if you rework fragments, we should be looking at. Another issue is if you do a mesh, and it's a layer 3 mesh routing over, you can't forward the fragments. You get to reassemble at every hop. Right? We don't have an official technique at the IETF on how to do that. And then if you go deeper into this question, there are issues like, oh, if I'm sending a number of fragments on my mesh network, as the first fragment progresses, it may interfere with the second fragment. I may be sending too many fragments in my mesh network, and I may be creating congestions. Right? So there are a number of problems which are associated with segments which are not solved by just saving a bit. I mean, it's important, saving bits is our life in this working group, but it's not the only thing. And so my suggestion is if we reopen the work on fragments, I would, we won't use 5 bits every time we want to change something. We have to look at the big picture and look at what we really want to do with fragments, which functions we want to support. So do like a requirement prime statement, this thing, what are those things we want to solve in this working group if we work fragments? And then we can look at exactly how we do it.
Okay. Do you want to respond to that?
Okay, so yeah, I agree that we may consider the wider picture. This moment, well, the main goal was to really have some more lightweight approach, which incurs lower overhead, and which additionally, because of the context in which this was designed, was able to support layer 2 MTUs, which are really, really low. But I agree that we should consider as well the whole greater picture.
Folks, we're actually out of time already. Thank you. Thank you very much for the presenters. Do we know where the blue sheets are? You have one? Oh, you haven't signed it. So at least one person hasn't signed. We should get 2 sheets back. Other than that, we're done for today. Thank you very much.
I'm looking for it.
Where's Bob? They were passed at the very beginning. Where's Bob Hendon? I have his video adapter. Did Bob Hendon leave? You can reach him? Oh, this is like a lifesaver. Yeah. Thank you.
Yeah.